Hey everyone, in today's lesson I'd like to show how can we create such an effect, which is quite simple but yet interesting. Uh, since it says the setup is not very complicated as usual, since we would like to get the job done faster and to save some time to spend with ourselves, families and friends. Okay, so let's see how can we achieve the type of effect. So here I have a few geometries that is considered to be as a low-res geometry. Okay, and then here we have the same type of geometry, but they consider it to be as a high-res geometry. They would like to drive in the end by the low-res ones. And here we have our distribution points. So in my case, in this case, I'm using the tube. I have few manipulations and I'm filling the tube with points, and then I'm randomizing my normals so I can have different directions of the geometry, and then I'm using this custom HTA that I use on a daily basis. I made it for myself. So there's a free version on my Boostion Patreon that you can use, which does the same job. So the main goal is to make a gradient that will gradually grow. So this way our white points are activators. This way we will activate from bottom to top. Okay, then a few manipulations and a custom attribute to be used later, and p-scale. So we start with a very low value and we will inflate from this to the final shape and scale of our geometries that we're going to use. So the first distribution will create the initial setup. So we create a small geometry that has very low p-scale. So as usual, um, we're using the switch and the metadata in our for each context. So I'm using the metadata by drag and drop into spare input, and using detail expression, I'm using the iteration attribute. And since we have 4 pieces of geometry, I'm using this modules by 4. So take one of the geometries and copy onto the point. Okay, and this is connectivity and create name attribute by using the assemble node. Since I test a lot and I'd like to have some additional attributes that I might use during the test, I kind of keep this attribute, and not all the time they're used in the end. So I try to keep them, and whenever I finally achieve the goal, I can simply use the attribute delete and clean up um, the final caches. Okay, so this way I'm adding a piece attribute and I'm creating the name attribute for the both of the setups. Here's the same. And here we have our points being activated. As you see, since we have our color being applied to the points, it will also apply to the geometry. the same with the second setup, but here I have increased my geometry scale onto a quite big value. Okay, as you see. So this is the final destination of the geometry growth that I would like to have in the end. Okay, and we have only the color distribution. And here with the first setup, I'm creating just in case a mask attribute, which is using the color. And here I would like to. So this one this one is going to be a mask, and this one is going to be the rest, which we'll be using our Vellum solver next. So here we're using the lerp expression to actually to grow our geometry from 0 to the final destination. Okay, so we have here the first input. A1 is the position of these points, B1 is the position of these points, and then position the lerp, use the color as the driver to blend the point position of the geometry. Okay, and as we see, all the geometry is intersecting that we will that will be fixed during the simulation. Okay, now in the Vellum solver, we are using the Vellum rest blend, and we're using our rest input. I mean, the rest geometry that we created, and we're using each frame. So I'd like to kind of track the geometry increase that we created here, right? And stop this one. And then I'm creating gravity force, and I'm using the active group. So it will work this way. So we have our increasing geometry, and then it will fall into active group, and then geometry will start falling down. And here I'm transferring the color onto our geometry, and then I'm creating this active group that I'm using in the gravity force, and then I'm deleting the color attributes. Okay, so this is the main setup, and I've cached the final result, so we can see our final simulation. And then since I have the same p scale, I mean the high res one has the same p scale as the low res one. I would like to simply point deform our high res geometry with the low res one. And also, since I have created this piece attribute, I haven't cached it, but we could try. You could try yourself by using those, since they have the same connectivity, and it might work. Okay, but since I got the result that I want, I haven't tested that. And then I'm adding a peak. so I could kind of close the gap of the of those deformations if it's too much. Okay, and then I'm deleting those 0 points for now, and then I'm randomizing colors, and I'm using that custom attribute I've created. With a random from attribute. And then I'm simply adjusting colors, just make it more kind of attractive, juicy. All right. All right, since I have some weird geometry, I simply deleted it. And this is a normal thing, because sometimes whenever you have a good simulation and you have a final result, some small tweaks, if it's possible, simply by deleting the geometry or points, whatever, this is normal. Nothing wrong with kind of a kind of decisions. Okay, and in the end, I'm simply I'm creating custom color attribute uh, that I'll be used during the render time. And yes, this is the final result that we'll have. And here I prepared a little render setup, but I will not go into it since my computer is very slow. It will take a lot of time to see the final result. Um, and yes, this is the final result. Well, that's all that I'd like to share in this lesson. And if you find it useful, please like and subscribe. And I'll see you in the future lessons. Thank you very much, and goodbye.